Good morning and welcome to the IFS UK and Ireland User Group Summer Conference. Thank you all for supporting our events. We've got a great turnout again today. I hope you have all had a good summer and have managed to take a break. For those of you who don't know me, my name is Amanda Miller and I'm the manager of the User Group. The User Group is run by a committee of volunteers who all work for IFS customers. We also have a couple of committee members who work for IFS and who assist us with liaison between our members and the company. The User Group is independent of IFS, which allows us the freedom to react to requests from our members. As members, we need you to stay in touch with us and let us know if ever you have any concerns or requests that you would like us to follow up on your behalf. The presentation today has been supplied by two of our members, both are customers of IFS, and the title is Service and Maintenance from an IFS and an FSM perspective. During this event, Hayley and Mike have taken 4 common scenarios and will discuss how each system handles them. Incident or fault logging, incident or fault resource allocation, incident or fault management, and incident or fault resolution. They've created word stories for each, describing the system process and key fields. Using screenshots, they will highlight the areas that are exactly the same and where they differ. If you've got any questions during the presentation, please ask them using the Q&A option. Please add your name to any questions so that we know who's asking, and I will put all the questions to our presenters at the end of the presentation. If we don't manage to get through all the questions, we will ask for them to be answered after the event. The event today will be recorded and the recording will be available to all our members on our website next week. So today we're very pleased to have as our presenters Mike Gosling, who is the Service Platforms Manager at Cubic Transportation Systems. He's currently responsible for the whole monitoring and trouble ticketing systems for EMEA services. Prior to that, he was in computing as a systems engineer. Mike has been using and implementing business systems for 22 years and has run successful projects within the UK and globally. Cubic uses the IFS, FSM and PSO systems. These take alerting and incident feeds from over 60k field assets alone on the TFLS ticketing systems. You're not actually going to see Mike today. He's pre-recorded his presentation. However, he is watching the presentation and will be able to answer any questions at the end remotely. And we also have Hayley Goldfinch, who is Business Systems Executive with the Port of Dover. Prior to working at the port, Hayley worked in the property sector for over 10 years, with roles ranging from mortgage administration, buildings and contents insurance, and property management. Hayley's been with the Port of Dover since July 2012 and first joined there as property executive for the Estates Department. She began working with IFS in 2015 when they implemented a bespoke estate module as part of the overall business implementation. This then led to the movement to the Business Change Department in 2017, where she continues to work with IFS and look at ways to improve other business processes and fully utilise the system. So that leaves me to hand you over to Hayley so she can get on with her presentation. And she's going to share some of the videos of Mike as well. I shall hand you over. You are Hayley.
Hello, morning everyone. Thanks for joining. So as Amanda said, I am Hayley. I've worked at the port for 8 years. I'm sure many of you have been through the port at some stage on your journeys to France. It's not just a ferry business we have. We also have a cruise business, cargo business, property, and marina as well. So we use IFS Apps 8 for all aspects of the business, from HR all the way through to finance. But we all have in-house engineering team who use the service and maintenance area, which we're going to go through today. But we also use it not just for reactive, it's all our planned maintenance as well. So I'm just going to load up my presentation. So that's just a brief intro from me. I'll just hand over to Mike and he'll do his intro. Hopefully this works. Sorry.
Hello. Sorry about this being a recorded demo. There were technical issues to do with Microsoft Teams. My name is Mike Gosling. I'm the Service Platforms Manager for Cubic Transportation Systems Limited, and we are the people responsible for the Oyster Card system in London, the Transport for London system that you may be familiar with if you've ever been to London. But we also have gates and things installed all over the UK. In my role, one of the key systems that we use is the FSM and PSO systems from IFS. They are right at the core of our field service. And it's a very complex configurable system. It's a large system, it's very powerful. And to do a full demo of that would take quite a while. And instead I thought it would be quite a fun thing to do. And that is to basically show that field service can be handled in various ways by different systems. And I know that the IFS App 8 has a customer service login system. So myself and Hayley have got together to throw this together just to show you that there are synergies between the two systems. Obviously, this is not a full demo of each system, and there are much more differences when you really drill into it, especially on things like the PSO. But I thought it was quite nice to show you that on a Venn diagram, there is quite a lot in common, and that field service and customer service has some core requirements that run through most systems you find. So this is just a fun presentation. It's nothing meant to be anything in depth, but again, I apologise for having to record this. But I will be online, and let's hope that you have some good questions afterwards.
Okay, so as Mike said, we're going to go through 4 sort of main scenarios of how we log a case or an incident, how we then allocate that using the resource allocation, how we do the planning of the work, and how the engineers carry out the work and get that information back into the core system. So in Apps 8, we've pretty much purchased all the modules in Apps 8. So there's a number of ways you can raise a fault. You can use the call center case wizard, new case assistant, or you can use, which will go into a case, or there's service requests or direct fault reports, which go into service and maintenance. So at the port, to simplify raising a fault for our internal customers, we use the new case issue. So it's a simple 3-box fields that they need to fill in. We've predetermined what categories are, and we've also put some prompts on the wizard itself to give some more information for the engineers. For our external customers, which are all our tenants and customers within the port, we use a new case assistant. So this links a bit more to the customer records that we have in IFS. So all customers and tenants in the port have a service contract with us, which is another module of IFS, and we can link this directly with support keys for all the SLAs that you might have. We've actually set up custom events in IFS so that any new customer that's created, it will automatically create a support key, and we just give standard SLAs for all customers, but obviously you can specify if you have a particular customer that needs different requirements for their service level agreement. So this will link directly to the customer record. As I said, with the service contracts, they will list out every asset that the customer is connected to. So using that link here, we can specify if it's one of the leased or demised areas that the fault belongs to. But if not, you can just simply untick this and it can be raised on any asset or functional object that you have in the system. This screen, similar to the issue, you select the category and give the details of the case and then the severity of the case. That will then ultimately turn into a case, and we've built using the escalation rules. Depending on which category is selected, it will determine which case queue that will go to. So we have various case queues in the business. We have all our different areas of engineering have a case queue, but we also use this for logging IT faults or legal requests for any agreements and things like that that are needed by our legal department. So you can see here it's defaulted to the engineering queue directly. They'll then determine whether a work order is actually required for the service and maintenance area. They'll come in and enter a task, and using the handover reference, that will automatically, once this record is saved, it will automatically create a work order in service and maintenance. If they feel the case isn't required for them, they can use the dispatch and send it to another case queue or an individual, or they can reject the case. As I said, because we don't just use this for engineering, it's also used for legal and IT. So they only use this case area. They don't go into service and maintenance at all. So this was just an overview to show you that everything is captured on a case, any status change, if it's been dispatched to anyone. So you can just use case fault logging. You don't have to use service and maintenance. So it's just an overview there to show you. So that's how we log a case at the port, or an incident. So nice and simple, very quick overview. I'll just hand it back to Mike now, and he'll show you how they do that in FSM.
Okay, my slides aren't as well put together as Hayley's. I'm not a graphic designer. I apologise about that. So FSM and PSO instant login. The FSM system has a contact centre that's used for logging, and they can be manually logged via the application, or they can be logged by a portal externally if you wanted to. And there are APIs that enable you to interface with other systems, and for example, IoT. And in Cubic, we have many feeds from all our equipment, and we are monitoring in real time in excess of 60,000 assets in the field alone, and those assets report back automatically log faults into the system. Now, some of the key features of the contact center are contact. I'm obviously, you can read the slide, but I'm going to go through them anyway. So contact. Now, this can be, it's not just a name, it's not just a place where you can put a field. It is in actual fact a whole contact system behind it. So if, for example, you get a caller, Joe Bloggs phones up, or Mary Smith, you can find information about that person that's pertinent to them, and it might help with your customer relations. If, for example, you do have a relationship with them, and it's like you can put anything on there from where their role in the business to a little bit of personal information if you want. Obviously, with GDPR, you have to be careful what you record nowadays, but it's a comprehensive system that you can attach to a record. If it's a new caller, a new contact, you can create a contact record on the Who's board if you want to. But again, if you just want to record just a name and a number, the system allows you to do that. So it's as comprehensive or as live as you want. The next obviously important thing is place and location. Place and location is typically where, in Cubic's world, the asset is situated. So if, for example, in Transport for London, where we manage the Oyster system, it could be a tube station. We also manage the docking points and terminals for London Cycle Hire, so it could be a docking station. And these can be automatically logged by the system, in which case we enrich them with the place, or the person who's logging the call can drill through and they can find the place via the name, the known as name, the national location code, whatever information they're provided by the customer. So the customer can verbalise it how they want, and it should be fairly quickly to be able to find it from that. The product is the asset that we're logging the job against, and there can be a single product, or there can be a hierarchy of products we want. We typically have a single product, and so, for example, we would log it against the gate, the walkway that you might walk through, or the ticket machine, or the reader. How you want to set your products up is entirely up to you. It can be very precise, it can be very big, but we find the best way to do it is because the customers often phone us up, and because we have contracts against certain assets, we log them against the contractual level of the asset and the customer's name of the asset. And that means that the product can be called anything that the customer wants to call it if you really want to. If they want to call their asset the thingamajig, we can call it the thingamajig on the system, but we can relate it to its engineering part number on the product record if we want to. Obviously, there is consistency. We don't go that far. We call our things ticket machines and we call them gates, and everyone knows that. But the system allows you to be flexible and call the product whatever you want it to be. Contracts, this is quite a strength on the system. It allows us, because it is a field service, allows us to have our target times. It allows us to the service day, the offering. It allows the labour rates. It allows all the sort of things you'd expect from a contract to be able to automatically create an invoice, for example. It's fairly flexible that you can have a contract on a specific asset, or you can have it on a place, or you can have it on a whole group of models, products, or you can have it on very individual serial numbers. How you want to do it, you can do it. The system's very flexible. And this is the core of recording against these events, against these times in the contract, enables us to record our service contract. We offer ticketing as a service, retail as a service, validation as a service. You know, we don't necessarily say that machine is gold, silver, bronze. We offer a level of retail ability for a whole station over the period, and it's maintaining that level of service over the entire period is important to us. And the contract framework allows us to capture that because of the service day and things that they put against it. Priority goes without saying. I mean, obviously everyone's aware of the concept of priority, but it's very powerful when you have equipment. For example, in Cubic, we have equipment in the public domain, gates and things like that. So we have health and safety issues. For example, a cycle terminal, someone could drive into it and cause problems. So our priorities are very important. Systems can auto log the priority based on a lot of rules, or it can be logged by the person. And I'll come back to how they're able to make that decision in a minute. Type, well, obviously in the service world, you have an incident, you have a service request, you have a problem code, you have preventative maintenance. The system can handle all of those. And there are business rules that enable the system to identify the type along with all the other attributes from all the other tables, and create the correct work package. And again, I'll come on to that. Categorization, very powerful for reporting, especially if you're auto logging. If you can do granularity of categorization, it's very good because it means that you can have levels of it, and you can pass this information back to engineering based on auto calling because it knows that it's this type of device, it's this type of fault, it's this type of error, etc. So categorization, it's very powerful. I mean, you don't have to use it, but we find that it's quite important, and for us, we backfeed this into our engineering. Status, obviously, is it open? Is it on hold? Has it been resolved? Has it been contractually resolved? All the sort of things that you would typically do for an incident. For our service, in Cubic, although field service is very different from ITIL, ITIL is the language that IT professionals talk, so we try to align ourselves with an ITIL framework for our statuses. Incident description, this is a text description. Again, some people say it's fantastic, you can collect all the information. From an analyst point of view, it's very difficult to report on text, so we try to limit it. So I'll come back to how we can populate that using templates later, but it can be useful, but again, it can be dangerous. So it's a balance basically. And the final thing is knowledge. Once you put all this information in, being able to call up knowledge articles, being able to call up history and things like that on the job is very powerful. And the system has a comprehensive knowledge system that enables you to go and identify documents, identifies web services, websites, all sorts of things you can open up. Very powerful.
Okay. So, excuse me. Right, I'll now go through how once the case has been converted into a work order, that will hit our engineering or service and maintenance area as a service request. Our engineers and team leaders will then pick up the work order and begin to prepare it. So you'll see information has already been populated automatically from the case. We've added a couple of custom fields here so that it references the case ID number, but you'll see all the information that the end user or the caller has entered will come through here onto the work order. So the engineers will then determine the specific asset that it relates to. We purposely left this so that it doesn't come through from the case because people that are not technically minded will tend to go for the top level asset when the actual fault could have been a smaller component that we need to get that data against. So we'll leave that blank for the engineers to complete. They will then determine which maintenance organisation or main org is used. So that's how we've split our engineering departments. So we have mechanical, electrical, buildings, assets, structural engineers, and that type of thing. So that's how we group our different streams of engineering. And then we have different work types. So whether it's reactive, if it's a contractor that needs to carry out the work, or if it's a planned maintenance. So if this work order has been created from a planned maintenance regime, that will determine the work type that's selected. And then we have the different priorities and criticalities. So you can just have criticalities that you enter on the work order, or you can have them set on the actual functional object, and then that will pull directly through. So if you have an asset that's critical to your business, you can set that on the asset level, and then any work order that's created, that will come through directly onto the work order. So, as I said, we have our different maintenance organisations, which you just list out as base data, so you can configure this how you wish. But we also have a craft catalogue. So every engineer or employee within the engineering area is connected to a craft, and then we can set hourly rates dependent on that craft, which I'll go on to a bit later about recharging. So we capture all costs on the asset, labour, parts and everything, so we can recharge that if we need to. So once the guys have done all their preparing, if you need to specify whether it's a contractor, this is linked to suppliers within the system. So as I said, we use IFS for pretty much everything at the port. So all our suppliers are listed out, so we can specify any one of those onto a work order. Team leaders will then put in planned start and finish dates, who the work leaders are, and who the work is going to be executed by. And as I touched on with planned maintenance, sorry, I'm rushing through this, there's obviously a lot more to this, but planned maintenance works will have a standard job connected to them, so this information will come through here. And within that standard job, you can specify different operations that need to be carried out as part of that check. I think they're now called tasks in apps 10, or maybe even in apps 9, I'm not too sure. But it's basically like a checklist for work that needs to be done for that specific job. And then because on the operations, you can specify which craft that element needs to be carried out by, you can then right mouse button and allocate the employees. And it opens up a new window that you put in the duration of the job. It will know what employees are connected to that craft, and you can click search and it will bring you back anyone that's available within that time frame for that time. And then that will appear down here who you've allocated that specific operation to. So that was a very brief overview of our resource allocation. There is a resource allocation Gantt chart within the system in apps 8, but it's very clunky. We don't tend to use it. We kind of rely on the knowledge of our team leaders, that they know their teams and they know who is available to do what and when. But there is the function there, but it's just not very user friendly. It's a lot better in the FSM, I must say. So I'll give you back to Mike now.
So now we get on to the FSM and PSO incident and fault resource allocation. And this is where the PSO system, planning and scheduling optimization system, really kicked in. It's an extremely powerful system that's dynamically schedules in real time resources to incident based on multiple criteria. Now I've detailed some of the criteria here, location, so where the engineer currently is and where they need to go. And it's not just where they need to go next. The system looks at the whole plan, so it's then after that, then after that, then after that, and even to their home location. The travel profile, are they in a car, are they on a train, are they in a tube? Cubic, we actually have two overlapping travel hierarchies. We have a tube one, because the engineers in London use the tube a lot to get around, and we have a road one. And they seamlessly work. There's no having to dip into one, have a look, dip into the other. The system knows exactly which one to use at which time. Skills is very powerful, so you can have broad brush skills, electrical or mechanical, or you can have very precise skills, reader management or microprocessor skills or ticket management, or however you want to do it. You can have more than one skill per activity, and you can have more than one skill per engineers, and you match them together to find the best person. And you can have flavours of skills as well. So you can have an expert or someone who's a novice, and then depending on the type of fault, you could send the right skills according to that. It is worth noting at this point that the more you have flavours and the more you have these softer skills, the system does become slightly more complex to be able to manage and to understand how it's making scheduling decisions. So we tend to use skill on, skill off most of the time because it makes it easier to decode, but there are a couple of instances where we have flavours of skills. Certification is very important nowadays, especially around about health and safety and things like that. Our engineers, for example, aren't allowed to work on an underground station until they've done the full fire course, the underground course, and that's one of the certifications they have to have. And you can have expiry dates for these, and you can do reporting of the expiry dates. You can say, oh, you know, this engineer is about to expire, so therefore they need to go retraining, and so on and so on. So it's very powerful as well, and it works with skills. Incident and contractual SLA is one of the key parts of the scheduling decision. How long do I need to, what time do I need to fix this by, and how important it is. So the best way to think about it, this is, you could have two jobs logged equidistant from an engineer in the middle, job A and job B, they're logged at exactly the same time. Which one did you go to? The travel's the same, they're the same skills, the same everything. Well, it turns out that the job A is a priority station considered important by the customer, therefore it has a different SLA, and therefore it trumps the B one, and it'll schedule into A first. Now the system's having to do multiple calculations of all these SLAs all the time, so it's balancing the SLAs, it's understanding SLAs, it's very important for the system. But once you do it, it means that you can have the vast majority of your jobs automatically scheduled, and then if priorities come in, the system will have a really good go at it because the priority will have a much higher SLA, etc. But if you can't do it, then the exception takes over. But it'll highlight it to you, it'll show you it's a priority, it'll show an exception. So SLA is a really important part of it. Place opening or access times. Differences between opening and accessing is potentially, but you can have a station that opens, but you can only access certain parts of it at certain times because of passenger throughput, for example. And knowing those is quite important so that it doesn't schedule an engineer to fix a gate at Victoria in the middle of rush hour, because you just can't get near the gates at Victoria in the middle of rush hour. So obviously if it's an important one, it's broken glass, then we'll send someone down there, but the system thinks about those. Another one that you can do, for example, is spare parts. If the system knows that the only way to resolve this particular incident is by changing a particular part, it can include that in the scheduling decision by looking at the stock available in the engineer's van. And if the engineer has one of those available, it will allocate it to him. If not, then you have to consider the time, and have to consider going to give up from stock. You have to consider all those sort of things. Engineer shifts is a very important part of it. Obviously, engineers start and end at a certain time. And engineer shifts is not just their time they're on, it's where they start, it's their lunch break, it's where they finish. So it takes all that into account. It takes, they might start at one place and finish at another for any reason, I don't know. And they'll have a lunch break. And the lunch break isn't always fixed at a particular time. It can move within a lunch break window. So it might, if they're starting, say, at 7 in the morning and finish at 7 at night, it might decide to be able to give them a lunch break between midday and 1:30, and it'll move that lunch break around. And the system could do fixed appointments as well. So if for example, they said, no, he must be here at this time, or an engineer must be at a particular place, you can fix the time to that, but not the resource, and it will decide on what resource it sends later on when it gets closer to it based on the best plan, or if you want to, you can fix it to an engineer straight away. And it's very powerful for where you've got places where there's very limited access, very limited control. The customer may have a remote office that's got some equipment in it. You have to sync up meeting with them and things like that. Now, there's loads more criteria of the system. It's a fantastic system. I strongly recommend it. If you haven't seen the PSO tool, in action. Go and get a demo from IFS. It's absolutely brilliant. This here is a view of that. It's an old version. I still use the old admin. We are using a new version in our places. We're actually rolling more and more out, but it's just the classic. If it's not broken, don't fix it. And I'm kind of just use this one now. But this here shows you the day snapshot. This is taken during the COVID crisis. So you can see that we still had jobs out there. We're not as busy as obviously we normally would be because of the fact that there's a lot less travellers, but we are still supplying the service to Transport for London. And you can see here the engineers going out on here. So you have the resources on the left. You can see their shift plans clearly, and you can see the activities being assigned to them. And the final one here is the event diagram. So, I mean, Hayley might want to talk about this as well, but you can see all of the skills and crafts. There are obviously teams are quite important, organisations in the middle, but the real difference between FSM is the fact that it dynamically schedules, it has a travel profile, it has a travel matrix, the planning. Dynamic scheduling is the biggest single differentiator from the PSO. And it's very, very powerful. I don't know what Hayley will say about the application side of it.
Okay, so yeah, just before I go on to my next slide, I just mention the skills part with IFS Apps 8. We are currently looking at linking our HR records to competencies for all our engineers. So we can specify if an engineer is got a license for a forklift, a license, something like that, and we will link that through to engineering so that we can, it's an added thing that we'll have on the crafts, that if that specific operation needs a forklift, it will know who has the valid license on their competencies on their HR records. And that also links through to training as well. So all the training courses, if they then need to have a refresher course on something, that's all linked through to HR and they can book the training record. So that's something we're working on at the moment. It's not quite there, but we're pretty much there. Okay, so right, I'll go back on to now the allocation of the work and how the engineers complete the work orders out in the field. So you can do this individually, allocating the work order one by one, or you can come over to the work orders overview screen. And it's a simple highlight all the ones that you want to transfer to mobile, right click and transfer. So once the guys get the work order through to their mobile work order app, they'll see any work orders they have there available. They'll click on that and it will give them a list of all the work orders that have been associated to them, and it will have a brief overview of what asset it is and what the actual fault is. You can configure these screens and the home screen to have as little or as more information on as you like. So the guys, once they get the work order, they can get a bit more information of the job, customer information on here. They can drill through to the actual asset to see any sort of relevant documents, asbestos reports and things like that. And then they'll accept, or if the work order is a duplicate or it's no longer required, they can reject it and give rejection reasons for that. So then once they've accepted the job, they will say that they're either en route or on site, and then go through and see any operations, so any tasks that needs to be completed as part of this work. They can order material, which we're working on at the moment, linking that to our stores and stock items, and any tools and facilities that are required for the job. So if they need a specific high lift to be able to carry out that inspection or something like that. So once they're on site, they can take as many photos as they like against the work order as well. This will link back to the work order in IFS as a media item. And then once they've completed the work, they'll fill in the report in screen, which will, they can say whether it was a reactive job or a planned job, what a brief overview of the different type of failures, which you can customize in your base data. And then we ensure that all our engineers fill in the work details. So this is what they've actually done on the job. You can talk this into the phone or type it into the mobile, and then that will automatically go back onto the work order. So once they've completed the work order here, that will set the work order to work done in the system. But we also use the app for taking energy readings, electricity meter readings, oil readings, which you can do here on measures. You can see all the assets that are pushed to the phone. We don't tend to push all of our functional objects to the phone because there's hundreds and thousands, so it'll probably just crash the app. So we just do the high level ones that the guys can select if they need to raise a new work order, which they can do directly from the mobile out in the field. They don't have to come back to the office to raise a fault. They can do that on the mobile as well. We also, I'll just briefly touch on this, pull work orders. So we have a lot of checks and PMs that need to be done on a daily basis, but there's not, or maybe over a course of a week, these checks need to be done, but they're not specifically have to be carried out by a certain individual. So this is where we use the main org groups. We have work orders and PMs that are specific to a main org. So anyone within that main org can then pick up these work orders during the week or during the day. Okay, so once the work has been done on the mobile, the team leaders come back and see on the single page reporting screen everything associated to that work order. So every status change, that will change the statuses of the work order. So as I say, when they completed the work order, it sets the work order to work done, not finished, so that the team leaders can do checks and approve time and any purchase requisitions that need to be raised on the work order. That can all be done before the work order hits historical. So as you can see, it's allocated all my time that I've booked on this work order. We've then got the report codes and the cause analysis and symptoms, which we can use for cause analysis data. And then the information that we have in the work details here, we've set up custom events. So now that this work order has been set to work done, that will update the task on the case as completed. And any information here that's been put on the work details, that will go automatically go onto the case and trigger an email to the customer that logged it, so they can see exactly what's been done and know that the work order has actually been completed now. So as I say, with the report in screens, there's two. So you can use single page reporting, which is a quick overview of everything, or you can go to just the report in work order. And from here, you can have the journal tab, and that will show you, as I say, every single status change that the guys have done. So the team leaders can come in at any point and see what position that work order is at. And as I said before, we have the recharging. So all those costs that were just on that work order with the labour, if it was deemed that that work was should be recharged back to the customer because it was actually their responsibility to repair, we can right mouse button and go over to transfer to work order lines. So this in here, you don't have to charge all the costs that have been associated to the work order. If you just want to charge the labour or the parts, you can define that here. You can apply discounts or uplifts if necessary. And then because we have a finance module within IFS, we run everything through here, and we can just right mouse button and that will automatically create an invoice to that customer. I believe you can do this to an external finance product if you have that. You can do like a CSV customization, but as I say, we have it all in-house, so it's pretty easy for us to just transfer and recharge that cost back to the customer. So that was pretty much the briefest overview I could ever give of service and maintenance and how we do handle sort of call login through to completion at the port. So I'll just hand back to Mike now for his final question, final presentation, sorry, but I'll be on the call obviously for any questions at the end.
So, as I said, the work packages from FSM get automatically scheduled down to the engineer on his mobile device. Now, at this point here, I'll ask you to stop reading what's on the screen for a second because I'm going to tell you something pretty cool. We monitor a lot of our equipment real time, and the equipment will pass an incident through into FSM. It knows that that incident can only be resolved by an engineer or remotely. If it needs an engineer, and we know it needs an engineer from the type of fault, it will automatically allocate that work package to a field engineer using the PSO. The PSO will automatically assign it down to an engineer. The engineer will receive that on their mobile device, and the real-time statuses back means that we can update any dashboards, we can update the job in real time, everyone knows the status of that job, and in fact our customers are able to also see that engineers are travelling on way. We share in some very powerful dashboards to our customer that can drill through to any job they want, right down to the status level and granular level. The engineer will arrive on site and they will resolve the incident. They will resolve it on their mobile device with their cause, action, symptom codes, parts used, and labour, anything that might be slightly different. Shut the job down, which shuts the incident down automatically, which will take off any dashboards. It will change the downtime. Any performance reports will be automatically updated. All that will happen. And the only human interaction with that is the field service engineer. Everything else has happened automatically in the background. And in fact, we don't always have an engineer. We can sometimes, if the engineer has yet to be formally allocated, the job is in the PSO, ready to be assigned, part of its backlog of jobs to be assigned, and we get a clear come through, the PSO can automatically pick that clear up, change the job to be automatically cleared, not send it down to an engineer, update the work package we've contractually shut, and in that instance, no one has touched the system. So that's pretty powerful. We'll record the downtime, how long it took to self-clear, and that'll be on all the performance boards, the customer can see it, and it'll affect our availability. So the fault resolution is an incredibly important part of our business, because availability, service, the hours our equipment is in service is key to us. We don't have a bronze, silver, gold. It is we have to provide a set number of hours of availability across all our each place. In fact, it's each zone within a station. So a station out in the middle of nowhere is equally as important to a station, a big station like Victoria or Waterloo. And in fact, one of the reasons for that is because TfL pride themselves on being able to give a consistent service to any customer, no matter what station they're in. So if someone uses our equipment in a big station and leaves via a tiny one, their interaction with our equipment should be exactly the same. This is what I've just talked about here. So we are able to contractually shut an incident down prior to the actual work packages being shut down. This means that if an engineer has been on site and has to change some parts, and he might have left some bits on site because he travels on the tube, we can then use the work packages that are there to manage the collection of those, pick them up, manage them back into our workshop. FSM has a full workshop and asset management system. Haven't talked about this today because this is about fault management itself, but it can manage those back. And then once it's back in stores and back as part of the workshop, we can shut the original work order down and we can kick off the workshop process. So resolution can be full resolution, it can be contractual resolution, and also it can be partially resolved. It may be that the system is put back into what's called a degraded mode of service. You might find this if you go to one of our machines. It might say that it's not able to accept notes, or it's not able to accept coins, but the machine is in operation. We're able to sort of change the way that we can put the job back in and manage someone else out to go and fix another part of it later. This is quite powerful from a contractual point of view, because at certain peak times we might be able to mitigate the fact that it was this and that. It's very complicated, but basically the system allows us to be flexible of when we resolve it. And these two screenshots that have been up for a little while now show you real-time events coming back and some of the notes coming back from engineers. So you can see that he's put some codes in, device was in service on arrival, but there was a fingertip maintenance job. Oh, I forgot to mention, there are certain jobs, for example, consumable jobs and fingertip maintenance jobs, we are able to decide that they are fingertip maintenance and consumable, and we send them to TfL, and TfL pick them up, process them in their ticket system, and send jobs down to their engineers to resolve via an iPad. Their station staff are able to then resolve the incident via their iPad, which will shut our incident down automatically. And so that's pretty cool that we're sort of we're passing incidents to a third party, be it TfL, and managing it back and shutting it all down. So incident resolution is another powerful part of the system. People often just assume it's shutting a job, but it's not. And then the final thing to say is that all this information that is captured is used for engineering analysis and engineer KPI, and to look at how effective we are with managing our engineers, to look how effective we are at fixing our equipment, and to look at root causes for trends, so spotting trends in types of faults that occur. And here, because resolution is so important, there are very few. Well, there are a couple, but generally, what you capture is your cause, action, symptoms, reflection, completion stations, and the parts of labour, and they're the core sort of things. So that's the end of the slide pack from myself.